Okay, angles in and around polygons. So question 1 states that A, B, C, D, E, F, G, H is a regular octagon. So it's got 8 sides. And you've got a straight line here, ADJ. And you're told that this angle is equal to this angle. Okay, and you've got to show that angle CDJ, so this angle here, this obtuse angle, is equal to 135 degrees. And that question is worth 4 marks. Okay, so how I'm going to approach this question? Well, first of all, you need to remember the formula for the sum of interior angles. I'm first of all then going to find angle BCD, so this angle here. Then I'm going to find angle CDJ, this one here. Okay, so this is the formula you need to know, and that is the sum of interior angles in an n-sided shape is the number of sides, n take away 2, and then times that by 180. Okay, so to find angle BCD, so this angle here I've labelled as 1, you need to remember that the number of sides in an octagon is 8. So the sum of angles is going to be 8 minus 2 times 180, which is 1080. So 1080 is the sum of angles. Now, since it's a regular octagon, all the angles are equal. So that angle BCD is going to be 1080 divided by 8, which is 135. So I've found the angle there, that is 135. To find angle CDJ, well, since angle ABC is equal to BCD, since this angle is equal to that angle, okay, and BAD, so BAD, this angle here, is equal to angle CDA, this angle here, okay, then this line here must be parallel to that line ADJ. So that side BC must be parallel to that line there, since it's a regular octagon and these two angles are equal. Okay, what that therefore means is that I can use the angle factor around parallel lines. And the angle factor I'm going to use is that alternate angles around parallel lines are equal. So this angle 1 and this angle 2 are alternate angles. Okay, because this is a parallel line, that's a parallel line, and that is a transversal. That's the line cutting them. So these two are equal angles, okay, since they're alternate angles, and so therefore angle CDJ is equal to angle BCD. So angle CDJ is equal to the angle I've worked out here, which is 135 degrees. So that question is worth 4 marks, and that's the solution there. Just make sure you give your reasoning for each part of the question. Okay, so question 2 states that the size of each interior angle, so inside angle, of a regular polygon is 11 times the size of each exterior angle, the angle outside. Work out how many sides the polygon has. Okay, so for this question, I'd underline the word interior, and I'd underline the fact that it's 11 times the size of each exterior angle. Okay, so you need to know the two formulae here, and the two formulae are these two. So the interior angle in a regular polygon is the sum of angles divided by the number of sides, and the exterior angle in a regular polygon is always going to be 360 divided by the number of sides. So I'm told that the interior angle is 11 times the size of the exterior angle. So this expression here is going to be equal to 11 times that expression there. So that's where that equation comes from. I've equated them. Now, if I then rewrite this, I'm going to rewrite this by simply doing 11 times 360, which gives me 3,960. And I'm going to expand this bracket here. That gives me 180n minus 360 divided by n. Now, because both sides of this equation have got a denominator of n, I can just simply cancel n on both sides. In other words, I can multiply both sides of this equation by n to give 180n minus 360 equals 3,960. So the n's just cancel each other out. Then using the balancing method, I'm going to add 360 to both sides. That leaves me with 180n equals 4,320. Then if I divide both sides by 180, since that's the inverse of multiplying by 180, divide that side by 180, I end up with 24. So the number of sides of that polygon is 24. Now you can always check this by putting this back into the original equation. So that question is worth 3 marks there. Make sure you follow it through all the way and understand what I've done. Question 3 states that RS and ST are two sides of a regular 12-sided polygon. RT is the diagonal of the polygon. So this is the diagonal here of the polygon. Work out the size of angle STR. So STR is this angle here. You must show you working. So that is 3 marks for this question, okay? So the way I'm going to break this down, first thing I'm going to do is I'm going to underline the word regular and 12-sided. I'm going to find, first of all, angle RST, which is this angle here. Then I'm going to find angle STR, which is the angle I need to find here. Okay, so the clue with this question is it's a regular shape. Okay, so that means that this side RS is equal to this side ST. So that forms an isosceles triangle. Okay, isosceles triangle. So before I use that fact, let's just find angle RST. So to find angle RST, which is this angle here, I've labeled 1. I'm going to use the fact that the angle is equal to the sum of angles in that shape, n-2 times 180, divided by the number of sides, okay, because it's a regular shape. So 12-sided shape, take away 2 times 180, divided by 12 would give 150. So this angle here is 150 degrees. Now, since it's a regular shape, like I said, this is therefore an isosceles triangle, okay? That means that this side here is equal to that side there, so therefore there's a line of symmetry down here, and so this angle here is equal to this angle here. It's isosceles. So to find this angle STR, which I've labeled as number 2 here, all I have to do, I have to subtract angle 1 from the sum of angles in a triangle, so 180, take away this angle here, 180 take 150, and then divide it by 2, because the remainder is obviously the sum of these two angles, which are equal. So that gives 15. So the answer is 15 degrees. Okay, so that question is 3 marks. Make sure that you give your reasoning for these questions and you'll get those marks. Okay, question 4. So you've got a regular pentagon ABCDE. So it's got 5 sides, it's a regular shape. And then you've got BCF and EDF are straight lines. And you can see that they meet at this point F here. Okay, so these sides are extended to form this shape here. So essentially you've got a pentagon with a triangle next to it. So I've got to find angle CFD. CFD is this angle here in the triangle. Okay, and I've got to show how I'll get my answer. So first thing I'm going to do is I'm going to find angle BCD, this angle here, because it's a regular shape. Then I'm going to find angle DCF. So DCF is this angle here. And then I'm going to find the angle that I'm asked to find in the question. Okay, so let's work through that then. Okay, so first of all, angle BCD. Since a regular pentagon, I can just do the number of sides, subtract 2, times by 180, that gives the sum of angles, and divide it by the number of angles I've got, because they're all equal, because it's regular. So that gives me 108 degrees. So angle 1 is 108. Okay, now, since BCF is a straight line, to find angle 2 there, to find angle 2, all I have to do is I have to use the fact that the sum of angles is 180 degrees. So I'll do 180, take away 108, that gives me 72. So that angle there is 72 degrees. So I found that angle there. Now, since these two lines meet at a point, okay, meet at a point, they must be equal. They must be equal, okay? And so because they're equal, okay, this forms an isosceles triangle. So these two angles would be the base angles in the isosceles triangle, and this angle here, the one I'm trying to find, would be the top of the triangle in a normal diagram. Okay, so the triangle just on its side here. So to find angle 3, I'm going to quite simply do 180 minus 2 times that angle I've found. So 180 minus 2 times the angle. Okay, so 180 minus 2 times 72, and that gives me the answer of 36 for 3 marks. Okay, you have to show how you got your answer with all these angles questions, so make sure you got your reasoning all the way through. Okay, question 5. You've got a regular octagon and a regular hexagon here. I have to find the size of angle X got to show all my working. So the way I'm going to do this is I'm going to find the interior angle here of this octagon. I'm going to find the interior angle here of this hexagon. Then I'm going to use the fact that the sum of angles around a point is 360 degrees to find angle x. So let's find angle 1 here. That's simply going to be, using this formula here, the sum of interior angles divided by the number of angles, because they're all equal. So that gives me, the number of sides is 8, 8 minus 2 times 180 divided by 8, 135 degrees. Okay, angle 2 here is same formula, I'm just applying it to a six-sided shape. So that gives me 120 degrees for this angle here. So I found those two interior angles. The only other angle around this point is the angle I need to work out. So since the sum of angles at a point sum is 360 degrees, I'm going to do 360 minus the two angles I found, and that gives me 105 degrees. So the answer is 105 degrees for 3 marks. Okay, remember, show all your working and give reasoning as well where appropriate. Okay, question 6. So I've got a right angle triangle here, and I've got a point P marked on the triangle as well, and a point Q marked on the triangle, and I know that AP is equal to AQ, and they've even marked that on the diagram here. These two sides are equal, so that essentially forms an isosceles triangle within this large right angle triangle. I have to find angle AQP, so this angle here. I've got to give a reason for each stage of my working. So first of all, I'm going to find angle QAP. QAP is this top angle here. Then I'm going to find angle AQP, which is what I'm trying to work out. Okay. So with this question, to find the top of this right angle triangle, well, I'm going to label this angle here as being 90 degrees, because that's what it is. This is 22. So just ignoring this line here, you can see that the top of this triangle, this angle here, angle 1, is going to be 180 minus the two other angles. Okay, just using the fact that angles in a triangle sum to 180 degrees. So that gives me 68 for this angle here. Next, angle AQP. AQP, this angle here. Well, since this small triangle is isosceles, I know the top angle here. Okay, to find one of the base angles here, all I have to do is do 180 minus this top angle and then divide by 2. Okay, so that gives me 180 minus 68 divided by 2, which leaves me with 56 degrees. So the angle there is 56 degrees. Okay, so that is 4 marks. Okay, make sure you give reasoning and show all your working for each stage. Question 7. I have a hexagon here. It's not a regular hexagon, as you can see, but it does have a line of symmetry. Okay, so the line of symmetry is straight down the middle here, as you can see. Okay, because FA equals BC, and you can see that FE here is marked as being equal to CD, and the markings there. I'm also told this angle is 117, but also the angle BCD is twice angle CDE, it's double this angle here. Okay, but neither of the angles here, okay, are given to you, so obviously you have to use unknowns, so it will involve a bit of algebra. Okay, I have to find the size of angle AFE, which is essentially this angle here, okay, which is going to be equal to this angle here, and showing all working. So this question's 4 marks. Okay, so first thing I'm going to do is I'm going to draw that line of symmetry down. Okay, so I've drawn that line of symmetry all the way down there. Okay, and since it's a line of symmetry, okay, it's cutting the shape exactly in half. Okay, so I know that this angle here must be 90 degrees. I know this angle here must be 90 degrees. Okay, now I can work with either side of this shape because it's symmetrical. I'm just choosing to work with this side here. Okay, but I could equally label these angles on this side here. Okay, so let me just call this angle here, which is the same as this one, let me just call it X, and since angle BCD, which is this angle, i.e. this angle, since it's double that angle, this is now going to be 2x. So that's x, and that's 2 times x. This is 117, because it's the same as that angle. So now I've got all 5 angles in this pentagon labelled up, even though 2 of them I don't know. Okay? Now, I'm now going to form an equation, okay, based on the sum of angles. Okay, so the sum of angles in a pentagon is going to be n minus 2 times 180. So n minus 2 times 180, well, n equals 5, this pentagon here. So 5 minus 2 times 180 gives me 540. Now, at the same time, that is the sum of angles. So that's 90, add 90, add 117, add 2x, add x. If I just simplify that side of this equation here, I end up with 297, add 3x. So I've just collected like terms there. So 540 equals 297, add 3x. And then using the balancing method, I can solve this equation. Subtract 297 from both sides. Leaves me 243 on this side and 3x. Then divide by 3 on both sides. X would equal 81. So x equals 81, but that's this angle here. I must find angle AFE, which is 2 times x, which is therefore going to be 2 times 81, 162. So that question is 4 marks. Just make sure that you've shown all your working, okay, and give your reasoning as well, and you'll get those marks. Okay, question 8 shows me a regular pentagon, and within inside it, I've got a parallelogram. Okay, so regular pentagon and a parallelogram, and I must find the angle x here. The only other information I'm given is the fact that this is 117 degrees. But also remember, this is a regular pentagon. Okay, so I'm going to answer this question by, first of all, labeling some of these angles around here. So I've labeled here, this angle is number 1. I'm going to find that angle first. Then I'm going to find the whole of this angle, which I've called angle 2. Then I'm going to subtract those two to find angle x, which I need for the solution. Okay, so how I'm going to do that? First of all, for angle 1, you know that in a parallelogram, from your knowledge on parallel lines, these two angles within the parallelogram sum to 180 degrees, okay, because they're co-interior angles. Co-interior angles, the sum of them is 180 degrees. So to find angle 1, just do 180 minus 117, which gives you 63 degrees. Now angle 2, okay, the sum of angles in a pentagon is going to be 5 minus 2 times 180. But then because it's a regular pentagon, I can divide that by the number of sides, divided by 5. That gives me 108. So angle 2 is 108 degrees. Now since I found this overall angle here and the smaller purple angle there, I can subtract those to give me the remainder, which is angle x, which is 45 degrees. So the whole question is 4 marks. Remember, okay, you have to show all your working, try and give your reasoning as well, and you'll get those 4 marks.